Good afternoon, students. Now, I want to explain about the chemical equilibrium. Now, I will discuss with Le-Chateliers principle. Now, I want to discuss with Le-Chateliers. Now, I want to discuss with Le-Chateliers principle in chemical equilibrium. We know A plus B equilibrium with C plus D. Means here this is a reversible reaction. This is a, we know this is reversible reaction. That is means the rate of forward reaction is equal to rate of backward reaction. Then only the equilibrium exists. The concentrations of each reactant will remains at equilibrium constant. We know this about at equilibrium. This much we already know. What will explain the Le-Chateliers principle? For example, if you want to increase the production of ammonia, for example, nitrogen reacts with 3 moles of hydrogen, they will form the 2 moles of ammonia. In this case, what will happen? Here, this is at equilibrium, the rate of forward reaction is equal to the rate of backward reaction. Means all the concentrations will remain. Initially, the nitrogen reacts with 3 hydrogen will consume. At initially, this is concentration is 0 at initial. After slowly, the concentration will increases the ammonia. Then at equilibrium, all concentrations remains constant. For this, we are not having benefits. What is the main Le-Chateliers concept? They will explain. If you want to, in industrial, want to increase the production of ammonia. If you want to increase the production of ammonia, what you want? If you want to disturb this equilibrium, it require to disturb this equilibrium. If you want to disturb this equilibrium, then for this what we require? If increases this concentration, then the formation of ammonia product will increases. Slowly, if you remove this ammonia converted into liquid, slowly we collect the ammonia. Then if you in order to balance this equilibrium, what you want to do? Increases the concentrations of nitrogen and hydrogen. This is for this purpose only we have to explain about the equilibrium and also the Le-Chateliers principle. What are the conditions will favor to increase the production of ammonia? This we want to discuss in mainly Le-Chateliers principle. If you want to concentration, what are the factors discussed? Now I will explain one by one. Now, we know all these things. Next, we will discuss what is the definition for this. I want to write the definition for this. If we change the concentration of, change the concentration, pressure, temperature, addition of inert material. This is very, very important. Concentration, pressure, and also the temperature, and also inert material to a reversible chemical equilibrium that is means would disturb the equilibrium, disturb this equilibrium. So equilibrium shift to nullify this change. For this, what we have to undo in to nullify this change. What will happen if you change the equilibrium concentration, if you want pressure or temperature or addition of inert material? These four are very, very, then only disturb 2, 3 and 4. If you change the concentration of either reactants or products, either pressure or temperature or addition of inert material to a reversible chemical equilibrium, if you change these four, what will happen? The equilibrium shift to nullify this stress, to nullify this concentration and pressure and temperature and addition of inert material. To nullify this, they will change that direction equilibrium. This is very, 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 very. This is about the Le-Chateliers principle. Explain about these four conditions: concentration, pressure, temperature, and addition of inert material. Next, we will discuss one by one what will happen. First, we discuss about the concentration. First, we discuss about the concentration. First, we discuss about the concentration. Concentration. What you know concentration means? Number of moles per volume. We know. That is expressed in molarity, normality, whatever, different terms. First, we take, for example, nitrogen. They react with hydrogen. They undergo equilibrium with 2 ammonia. What is happening? This is exothermic reaction. We know delta H. Later we discuss about. If increases the concentration of nitrogen or hydrogen, what will happen? If increases the concentrations of nitrogen and hydrogen, this equilibrium shift towards the formation of ammonia. In order to decrease this concentration, the equilibrium shifts towards the forward direction. The equilibrium shift towards it. If you want to increase the concentration of ammonia, what will happen? If you increase the concentration of ammonia, then the equilibrium to decrease the concentration of ammonia shift towards this direction, formation of nitrogen and hydrogen. Means here backward direction is favorable. If it is transferred to that direction, if it is not, if you disturb this equilibrium, completely remove this ammonia from this reaction, what will happen? If increases this concentration, the equilibrium shift towards the formation of ammonia, means this is increases this concentration. If if you remove this, converted to in liquid state. This is the direction. The whatever the concentration of the either reactions or increase the products, the equilibrium shift to opposite to that direction. This is about the this is the concentration you have to remember. In different equations we can discuss. Next, I want to explain about the next effect of pressure. Next, change in pressure. What will happen? Second one is change in pressure. Change in pressure. Change in pressure. You must remember, very important, it is rule. If pressure increases, the equilibrium will shift towards the less number of moles side. This is very important. Put star mark. If pressure increases, the equilibrium will shift towards the lesser number of moles side. This is very important. How I will explain now. For example, if you take N2O4, 1 mole of equilibrium with 2N2. N2O4, the equilibrium with 2 nitrogen dioxide. This is the gases. This is the gases. We know according to ideal gas equation, PV is equal to nRT. Pressure is equal to number of moles V into RT. Means pressure is directly proportional to concentration N by V. We know number of moles per volume. According to Boyle's law, what will happen if pressure is inversely increases, volume will be decreases. Pressure is inversely proportional to volume at a constant temperature. We know this one. If what is happen if you take any cylinder like this gas, this is the gas, you put the number of moles, whatever it may be. If you apply the pressure, what will happen? The volume of this one is decreases like this. The number of moles, what will happen? The number of moles per unit volume, what is happen? Number of moles per unit volume increases. If pressure increases, the number of moles per unit volume increases. Why? Because if pressure increases, the volume will be decreases, because inversely proportional to. If pressure increases, volume decreases. If number of moles occupy the per unit volume, what will happen? Increases. What is happen? If it is more volume, the number of moles occupies will be less. Per unit, if this is total volume, per unit volume taken as a less number of moles. If the volume will be decreases, more number of moles will be occupied compared to the pressure increases, number of moles per unit volume also increases. What is the equilibrium condition? If you want to change this one, the equilibrium shift towards the less number of moles side. Understood or not? Less number of moles side. The equilibrium increases the pressure, the equilibrium will shift towards the less number of moles side. For this, what is happen? Delta Ng, if you want to find out, means number of moles of products minus number of moles of reactant. number of moles of product is 2, number of 1, that is equal to 1 mole. Means here 1 mole, here 2. If increases the pressure, the equilibrium shift towards the this backward direction, means less number of moles side direction. Backward direction is the equilibrium will shift, because we know already I explained pressure is inversely proportional to 1 by V. Pressure is equal to, we know, 1 by V into RT according to ideal gas, means directly proportional to N by V, number of moles per unit volume. If pressure increases, what will happen? Number of moles per unit volume also increases, volume decreases, the number of moles occupied per unit volume increases. If pressure increases, number of moles increases, the what is the equilibrium? Equilibrium shift towards the, if number of moles increases, equilibrium shift towards the less number of moles side. In order to the increasing of number of moles, to cancel this one, the equilibrium shift towards the less number of moles side. That is the condition already discussed. Very important. You have to remember, pressure increases, the equilibrium will be shifted towards the less number of moles side. Must remember this point. Next we discuss about the effect of temperature. Next we discuss about the change in temperature. Next, third one is change in temperature. Change in temperature. Next we discuss about the change in temperature. To discuss about the change in temperature. If temperature increases, what will happen? If temperature increases, the equilibrium shift towards the temperature increases, very important. The equilibrium will shift towards the absorption of heat side. The absorption of heat side. The equilibrium will shift towards the absorption of heat side. This is very important. The equilibrium will shift. If temperature increases, the equilibrium will shift towards the absorption of heat side. This is very important. The change in temperature. For example, if you take the equation A plus B gives rise to equilibrium with C plus D. This is the heat. Here what will happen if temperature increases like this? Temperature means this is by absorbing this heat, the equilibrium with it will form C plus D. Means it is a forward direction will favor. Forward direction, equilibrium shift towards the forward direction. Very important. If temperature increases, the equilibrium shift towards the absorption of heat side. This temperature is converted to in the form of heat, that by absorbing that heat, the equilibrium shift towards the forward direction. If temperature decreases, the equilibrium shift to the release of energy, means backward direction. Backward direction is favorable. You must remember this one. Simply you have to remember change in temperature. If delta H is positive, temperature, higher temperature will be favorable. If heat change of enthalpy, delta H is equal to negative, lower temperature decreases will be favorable. This is have to remember. Very, very, very important. You take any equilibrium, this is very, very important. If delta H is positive, temperature increases, higher temperature will be favorable. Delta H is negative, temperature, lower temperature, the equilibrium shift towards that direction. You must remember, if the temperature increases, the equilibrium by absorption of heat to if shift towards the by absorption of heat side. This must you have to remember. Next, fourth one. After that equilibrium, later after that discussing the four effects change. Next, one by one we will discuss equilibrium, different equilibriums. By taking examples, we will discuss. Next, fourth one is addition of inert material by the addition of inert material by the addition of inert material. By addition of inert material, whatever the material you have to add, this must be, it does not react with the reactants and with the products. This must be, this condition must be happy to satisfy. Whatever the addition of inert material, it does not react with the reactants or products. Now must remember, one is at constant volume by addition of no effect by addition of inert material. At constant pressure the addition of inert material shift towards higher moles side. The equilibrium at constant value, no effect. At constant pressure, the equilibrium shift towards the higher moles side. This how to remember. For example, if you take one of the PCl5, it is decomposed with equilibrium with PCl3 plus Cl2. This is all our gases. All are gases. All are gases. What will happen? This is for this, by addition of inert gas material. By addition of inert material. Inert material means, what is the concentration? Number of moles per volume. This is the concentration. Generally we know this is number of moles. This is the number of moles. What will happen? See here, by addition of inert material, this moles initial concentration means we have to consider this only. This number of moles means this is participant moles. This is does not change. Number of moles, these are the participant moles, that will remain same. But by addition of this inert material, what will happen? The volume will be increases. Volume will increases. By addition of this one, what will happen? By addition of inert material, volume means this number of moles does not change, but due to volume increases, the number of moles per unit volume decreases. Number of moles per unit volume decreases. Number of moles per unit volume will decreases. Means this is total mixture volume. This is total mixture volume. Due to addition of this inert material, total mixture of the volume will increases. This means this is a original participant. This does not change. Number of moles. This is a participant, equilibrium participant moles. This one, 1, 2, 3. This is not affected by addition of inert material. By addition of this is considered, number of moles is considered a participant moles. If you after adding this addition of inert material, what will happen? Total mixture volume will increases. Total mixture volume increases. That's why what happened? If volume increases, if for example if cylinder volume increases, number of moles occupied by per unit volume decreases. Number of moles per unit volume, number of moles is decreases. What for this, after that what do we want to change? Equilibrium. If decreases means in order to increase that one, the equilibrium shift towards the increase the number of moles side. Increase the number of moles side, the equilibrium shifted. That's why at constant pressure the equilibrium shifted towards the higher mole side. At constant volume, no change, no effect. If you put this constant volume, no effect, because the volume does not change. At constant pressure, what is happened? By addition of inert material, the total volume of the mixture will increases. Per the original participant number of moles occupied per unit volume will decreases. In order to increase that one, the equilibrium will shift towards the higher mole side. This is must you have to remember. Many students are confused here. You must have to remember. Thank you. Next, we will discuss one by one favorable conditions for different equilibrium constant. Now, I will explain. First condition is, what is this one? For concentration. For concentration, what is happen? If increases the concentration, what is the equilibrium? Equilibrium shift towards to decrease the concentration. Second one, what is the second one? Effect of pressure. Effect of pressure. What is this effect? If pressure increases, the equilibrium shift towards lesser moles side. Lesser moles side. Lesser moles side is increases. Lesser moles side, that is gaseous moles. Gaseous moles. It is third one. Third effect is what? Effect of temperature. T. If temperature increases, what is happen? Means, you know, endothermic means delta H is positive. If temperature T increases, endothermic reactions favorable, means delta H is positive by absorption of heat. Then is next, fourth one is addition of inert material. Addition of inert material. One of the condition that this inert material does not react with the either reactants or products. What will happen? This addition of inert material, we know, at constant volume, no change. At constant volume, no change. At constant pressure, equilibrium shift to more number of moles side. More number of moles side, that is gaseous side. These are the four conditions explain the Le-Chateliers. Very, very, very important. You have to remember. These are the four conditions you must be remember, if concentration increases, the equilibrium shift towards the lesser number of concentration side. The effect of pressure, what will happen if pressure increases, the equilibrium shift towards the lesser moles side. If temperature increases, the equilibrium shift towards the endothermic reaction. By absorption of heat, the equilibrium shift towards the endothermic reactions. If addition of inert material at constant volume does not affect, at constant pressure, the equilibrium shift towards the more number of moles side. By taking one or two equilibriums, we will explain one by one. If you take, for example, one or two equilibriums, then we discuss what is. For example, if you take H2 plus I2 give equilibrium with 2HI, means plus 3000 kilocalories. Then what are the favorable conditions for favorable condition for maximum yield of product HI? Product HI. For this, first you have to, what are the favorable conditions? First, concentration, means by increase the concentration of hydrogen and iodine, the equilibrium shift towards the forward direction. Well, this is one of the condition. Forward direction to increase HI concentration. Next, what is second condition? Effect of pressure. If pressure effect is there, have to calculate first this delta Ng. Delta Ng is 0. No effect of pressure. Here, no effect of pressure. Next, third you have to take. Third one, what is third one? Temperature. What is happened? Temperature either increases or decreases. This is the exothermic reactions. Means here delta H is equal to negative. Means if temperature decreases, this is the favorable condition. Next, what will happen? Fourth one, addition of inert material. Addition of inert material. Any effect? No, does not affect. Means delta Ng is 0. Delta Ng is 0 means there is no effect of this for this addition of inert material, no use. Only these two conditions, either increase the concentration of hydrogen and H2, then only they will increase the product, and also by lower temperatures, decreasing the temperature, this is more yield will be formed. These are the favorable conditions for this formation of hydrogen iodide. For example, if you take, if you want to take one more equation, this is nitrogen reacts with 3 hydrogen, they will form 2 moles of ammonia. Delta H is equal to minus 22.5 kilocalorie per mole. What are the favorable conditions for formation of ammonia? Favorable condition for more yield of ammonia. What are the favorable conditions for more yield of ammonia? First condition is concentration. First is either increasing the concentration of nitrogen and concentration of hydrogen, then forward reaction is the increases the concentration of ammonia. First condition. What is the pressure effect? Second one is pressure. pressure effect. If pressure increases, the equilibrium will shift towards a less number of moles. That means here delta Ng is negative, means -2. That's why if pressure increases, they will favor the forward reactions. Lesser number of means formation of ammonia side. What is happen if temperature? This is the exothermic reaction. That's why lower temperature decreases the temperature, then they will form the formation of ammonia increases, forward reactions. What is happen? Inert material. Fourth one, inert material. Inert material. What happened by addition of inert material? More number of moles side will be favorable. More number of moles means this is the backward reaction is favorable by addition of inert material. That's why it does not add the inert material. Only these three conditions will favor the formation of ammonia in Haber's process. This is Haber's process. What are the conditions? By either increase the concentration of nitrogen and hydrogen, or increase the pressure, or temperature decrease. Not very low temperature, it is moderate temperature will favor the formation of ammonia. This is explained about the Le-Chateliers principle. Now next we discuss about the another topic, that is degree of dissociation. This is about the Le-Chateliers principle. This is very important. Next, I want to discuss about the degree of dissociation. What is degree of dissociation? Degree of dissociation. This is denoted with alpha. Definition for this: the number of moles dissociated per number of moles dissociated per mole of the reactant. Number of moles dissociated per mole of the reactant, that is known as the degree of dissociation. Shortcut we write it as the DOD. Number of moles dissociated per mole of the reactant. For example, if you take PCl5 is decomposed to, they will form PCl3 plus chlorine gas. What will happen here in this degree of dissociation? How to find out? Initially, if you take, initially it is 1 mole. What is happen at equilibrium? At equilibrium, how much mole will react with alpha moles? If you take alpha minus alpha moles will be 1 mole. 1 minus alpha will be decomposes, will form alpha and alpha. If you take for example, if it is 0.4 mole, maybe some dissociated, then how to write it? If you take 0.5 moles alpha is, you write it as a alpha. What is the condition for alpha? Alpha must be either equal to this one or less than to this one. More than this is not possible because number of moles is 1 mole only. For 1 mole, either you have to equal to 1 mole dissociated or less than to this 1 mole will be dissociated. More than that is not possible. That's why alpha is less than or equal to the 1. Must be alpha is less than or 0 to less than or equal to, either 0 means alpha degree of dissociation is 0, either equal to 0 or equal to 1 or less than to 1. This is the condition for alpha. Must be, this is the condition for alpha. Either for 1 mole, this is dissociated like this. If you take here it is initially 5 moles. How to write it? 5 minus 5 alpha. Then it will form 5 alpha and 5 alpha. If you take C moles, what is C moles? How much is dissociated? C minus C alpha, C alpha, C alpha moles will dissociated. This is very important concept in calculation of equilibrium, degree of dissociation, and also the equilibrium constants. For the writing of this expression is very important. If it is alpha is 0.4, how to write 1 mole? 1 minus, if it is 5 mole, for 5 moles, PCl5 is decomposed to PCl3 plus Cl2. If it is initially this is 1 mole, this is alpha 0.4. How initially it is 5 moles. How we write it? Initially it is 5 moles. 5 minus 5 alpha, 5 into 0.4. Totally less than to this one only. The alpha must be 0 to 1. Number of moles dissociated per mole of the reactant. Per mole of the reactant. This is known as alpha. Initially, if you take 1 mole, you write the 1 minus alpha will be dissociated. This is alpha. If it is take 5 moles, 5 minus 5 alpha will be dissociated. If it is C moles, C minus C alpha moles will be dissociated. This is the alpha. Alpha is equal to number of moles dissociated per mole of the reactant. That is the number of moles dissociated. How many moles here dissociated? C alpha moles will be dissociated. C alpha by per mole means how much? How many moles? Here 5 moles we taken. Here C moles we taken. That's why C will get cancelled. Then we get the alpha. This is the expression, writing the expression for degree of dissociation. This is the meaning of the degree of dissociation in calculation of this one. Next, if you want to percentage, we take multiply with 100, then we will get the in case of percentage. Next, we have to solve the problems. Next, I want to explain about the problems. Take the question. H2 plus I2 equilibrium with 2 HI are reverse automated. 2 HI gas equilibrium with H2 gas plus iodine gas. Have to remember, very important. If degree of dissociation is what is done is for HI is alpha. Degree of dissociation for HI is alpha. Calculate the equilibrium constant Kc expression Kc expression for this. Calculate the equilibrium constant expressions Kc. Options are alpha square by 2 into 1 minus alpha square. B is alpha square by 4 into 1 minus alpha square. C, option C is alpha square by 2 into 1 minus alpha whole square. D is alpha square by 4 into 1 minus alpha square. These are the 4 options they have given. This is calculate the expression, equilibrium expression Kc for this expression. How to calculate this expression? First you have tried this is 2HI, this dissociated, they will form hydrogen gas plus iodine gas. Initially this is taken as whatever moles. Initially we take 1 mole. Here at equilibrium, we take how much we discussed? 1 minus alpha. Before this I discussed 1 minus alpha. How much here? 2 moles is consumed, they will form 1 mole of hydrogen, they will form 1 mole of iodine. Here means 2 moles 1 mole, means this is alpha moles. This decomposed, they will form alpha by 2. This is alpha by 2. For this Kc expression for constant, they have given as, if not given volume, then it is considered as a 1 liter. Kc is equal to concentration of hydrogen to the power of 1, concentration to the H to the power of 1 by Hi whole square concentration. What are the concentrations of this one? This is iodine. Concentration for iodine is alpha by 2 into hydrogen is alpha by 2 per volume. Alpha by 2. Hi concentration is 1 minus alpha square. This we know. Alpha by 2, alpha into alpha. Alpha square by 4 into 1 minus alpha square. This is the expression for answer. Option D is the correct expression for this equilibrium constant. Kc expression for this Kc. Next we have to write the next equation is very important. This is simple one. Next we have to discuss. Next question is very important. If this is important question, if this is N2O4 gas equilibrium, they will form 2NO2 gas. For this, alpha is 0.25 at 1 atmosphere pressure. Then the value of Kp is, the value of Kp is close to, this is important question. This is options here. A is 0.25 atmosphere. Option B is 0.50 atmosphere. Option C is 0.65 atmosphere. Option D is 0.85 atmosphere. Then have to calculate this. First we have to write the equation for Kp. First you have to write down the what is the condition. If write the equilibrium equation, gas equilibrium, they will form 2 into NO2 gas. We write the initial moles. Initial is take as 1 mole. At equilibrium, what will happen? 1 minus alpha. 1 mole is converted to 2 moles. That's why here 2 alpha. Add on. For this, if you take, for example, we know already for expression for partial pressures. If you take Na mole, Nb mole, 2 moles. What is the pressure? Partial pressure of gases A, Na and Nb. Partial pressure of A is equal to number of moles of A by total number of moles into pressure. This you know. Means either number of moles of A plus number of moles of B. This is the expression we already in gas state we discussed. For this, number of moles for this is how many moles? What is the partial pressure of A per partial pressure of N2O4 is equal to number of moles of, that is 1 minus alpha by total moles is 1 plus alpha into pressure P. Next, partial pressure of NO2 is equal to number of moles of, that is 2 alpha by 1 plus alpha into P. This is the partial pressures of N2O4 and partial pressure of NO2. Next we have to write down the Kp. what is the Kp is equal to expression partial pressure of NO2 whole square by partial pressure of N2O4. This is partial pressure of NO2 whole square, means this is the 2 alpha by 1 plus alpha into P whole square divided by 1 minus alpha by 1 plus alpha into P. If you want, this is pressure cancel, this is what will happen, this is the square, only one pressure is there. If you want to cancel this one, next 1 plus alpha will cancel, only 1 plus alpha exists, this is square. Next, what is the expression how to write down? That is 4 alpha square into P by 1 plus alpha into 1 minus 1 means 1 minus alpha square. This is the Kp. Here they given a 4 alpha is given 0.25. 4 into 0.25 pressure is 1 atmosphere divided by 1 minus alpha square. Alpha is 0.25 whole square. Means 0.0625. This one 1 minus means compared to 1 this is very less than 1. That's why this is taken as a 1. 4 into 0.25. 4 into 0.25, here is alpha square means square. This is 4 into 1 by 4 into 1 by 4, 0.25. 4 cancel, 1 by 4 means 0.25 atmosphere. This is the option A is the correct one. You know, if N2O4 dissociate, they will form 2NO2. Write the equation. Initial 1 mole, 1 minus alpha, 2 alpha. We know partial pressure according to gaseous state, gaseous law, Dalton's law of partial pressure of A is equal to number of moles of A by total moles into pressure. Same like that, we have to write down the partial pressure of N2O4 individually. Then we write the expression for Kp, substitute those values, then find out the total pressure Kp for this 0.25 atmosphere. Next, I want to explain about the. Next, we will discuss about the next we will discuss about the next this is about the degree of dissociation now discussed. Next we discuss about the alpha and next I will explain alpha and next I will explain alpha and observed molar mass, observed molar mass and observed density. These are the terms. This is next, this is also important. Alpha, observed molar mass and observed density. Very important. This concept also have to very important. Next I will give the one of the important N2O4 equilibrium with 2NO2. These two are gases. N2O4 equilibrium with 2NO2. The observed molar mass at equilibrium of N2. The observed molar mass at equilibrium is what is how much? Equilibrium is N2O4 of N2O4 is 80 gram per mole. 80 gram per mole. Calculate alpha. The observed molar mass at equilibrium of N2O4 is 80 gram per mole. calculate the alpha. Here, like this, they will give the question. How to find out the alpha? This is given as an observed molar mass. Here, you see, this is the observed molar mass. The actual molar mass of this N2O4 is how much? Original molar mass of N2O4. Nitrogen is 14. Molecular atomic number is 7. Molecular weight is 14. Here oxygen is 16. This is 28. 2 oxygen 64. This is 92. This is the original molar mass at initial, means before this equilibrium. This is initial one, like after equilibrium they have given observed molar mass at equilibrium N2O4. At equilibrium this mass is mixture of mass. This mass means this is having average molar mass. Why? Because initially they having original molar mass of N2O4 is 92. This is before this equilibrium reach. After equilibrium the molar mass of N2O4 is 80 gram. This is average molar mass. Why? Because this is calculated experimentally. Means this is at equilibrium. Equilibrium they be having both are in equilibrium, they having mixture. That's why this is the observed molar mass is a average molar mass, mixture of molar mass. The original molar mass is this one, 92 grams. This is the mixture of molar molar mass. This is the initial molar mass. This is at equilibrium. This is in original molar mass. Next, if you take for example, how to find out this equation? O2 gives rise to nitrogen. This is 1 mole. We take mixture. How to find out the average molar mass? Average molar mass is equal to total molar mass by number of moles. This is total number of moles. Then by using this we have to find out the average molar mass is equal to mixture of molar mass. Total molar mass by mixture means mixture molar mass by total molar mass by number of moles. Total molar mass of mixture means this is by addition of these two plus total number of moles. That is the average molar mass. We have to find out this observed or average molar mass of that equation. This here, for example, if you take the A equilibrium with NB. For example, if you take this equation, this is initial one. This is 1 mole. Here 1 mole will form NB mole. Means here 1 minus alpha gives N alpha at equilibrium. This is the average observed molar mass. If you take for example, this is observed molar mass. That is M observed is equal to M real by means total mixture is total number of moles. Means here M real means what is the M real? This is the M real means what is the M real here? Total number of moles unit is 1 minus alpha base. This is divided by, if you take M real by 1 minus alpha plus N alpha. This is equal to M real by 1 plus N minus 1 alpha. This is the equation for this molar mass. If it is this is the total number of moles mixture observed. This is the mixture observed. This is the M real. This is the molar mass of the M mixture observed. This is the M real. Molar mass of the observed is equal to molar mass of the real by total number of moles. Total molar mass of real by total number of moles means 1 plus n minus 1 alpha. This is the M observed calculated by using this equation. For this, how to solve the problem? We know M observed is equal to M real by molar mass of real by 1 plus n minus 1 alpha. How many are n minus 1? N is how much? Delta Ng is equal to 2 minus 1, that is 1. N minus 1 is 2 minus 1 into alpha. Here, this is 1 plus alpha. M observed how much? M observed molar mass 80 is equal to M real how much? 92 by 1 plus alpha. 80 plus 80 alpha is equal to 92. 80 alpha is equal to 12. 8 from this side. Alpha is equal to 12 by 80. Means 3 2 ja, 4 2 ja, 4 3 ja. 3 by 20 into 100. You have to percentage calculate into 100. 3 5 is 15%. The alpha is 15%, 0.15. Means if you want to find out this one, means if you want to multiply with 100, this is 15, 0.15. Alpha is 0.15. Means here we get alpha is equal to 12 by 80. Means 3 by 20. This is 3 by 20. Next, how what is happened? 0. If you put 0 here, 3 1 ja, 20 100 5, 0.15. Alpha is 0.15. This is the alpha for observed molar mass and observed density. Observed molar mass M observed is equal to M real by 1 plus n minus 1 into alpha. This observed one is the at equilibrium. This is mixture of molar mass that is determined experimentally. This is the original molar mass. This is at initially they having the molar mass. By using this, you can find out the alpha. This is the M observed is equal to M real by 1 plus n minus 1 into alpha. Next, from this, we know vapor density is equal to, this is the formula, M observed is equal to M real by 1 plus n minus 1 alpha. This is the equation for this. We know 2 into vapor density is equal to molecular mass. We know this is molecular mass is equal to 2 into vapor density. Here 2 into vapor density of observed is equal to, this is 2 into vapor density of real by 1 plus n minus 1 alpha. This here you cancel 2 2. Vapor density that is denoted with that is denoted as a, if observed one is taken as a small d is equal to, this is denoted capital D by 1 plus n minus 1 alpha. This is the D observed is equal to capital D real by 1 plus n minus 1 alpha. This is the expression for density. In case of mass, this is taken as small, this is taken as capital mass. This is molar mass of real. This is smaller one is observed mixture. This is the formula for these two equations. This is alpha. How to find out? Next, observed molar mass and observed density. For the density, this is the formula. For molar mass is, this is the formula. This is about the degree of dissociation and alpha and observed molar mass and observed density. By using any calculations, we can derive alpha easily. Thank you students. Thank you. We'll explain next.